That ordinary cardboard box hides an incredible journey of wood fibers, recycled paper, steam, glue, and precision machinery. Most people never think about this, but a box begins long before cardboard reaches the factory floor. The main ingredients are fresh wood fiber, recovered paper, water, energy, and carefully controlled starch-based adhesives. Fresh fiber commonly comes from managed forests, while recovered fiber arrives from collected cardboard and other paper products. Recovered cardboard isn't perfectly clean. Workers and machines remove plastic, staples, labels, grit, and other unwanted materials. The cleaned paper enters giant pulpiers, where water and powerful agitation separate the fibers into a thick slurry. Fresh wood follows another route, becoming pulp through processes that separate useful cellulose fibers from unwanted material. Those cellulose fibers eventually become huge rolls of containerboard, ready for the most important transformation yet. These rolls contain different papers, strong liners on the outside, and a special medium destined to become the waves inside. And this is where everything changes. Flat paper is about to become the strong, wave-shaped structure we call corrugated cardboard. Inside the corrugator, the flat fluting paper meets heat, moisture, and specially shaped rollers that create its famous waves. The rollers press the softened paper into repeating arches, creating an internal structure that can resist crushing surprisingly well. The rollers press the softened paper into repeating arches, creating an internal structure that can resist crushing surprisingly well. Once the waves form, a thin layer of starch adhesive coats only the flute tips. Then the first liner meets those adhesive-covered peaks, forming a bonded single-face corrugated web. The single-face web races forward while another liner approaches, preparing to close the opposite side. The second liner joins the structure, creating the familiar three-layer sandwich found inside countless everyday shipping boxes. Controlled heat and pressure help the starch bond develop, while the freshly formed board travels beneath long heated belts. For heavier shipments, manufacturers can combine additional fluted layers to create stronger double-wall or triple-wall construction. Now the transformation is complete. Endless flat sheets of paper have become wide, strong corrugated board ready for box production. The giant corrugated sheet now enters a precision cutting line, where its final box shape begins to appear. Rotating knives and cutting dies create panels, flaps, slots, and fold lines with remarkable repeatable precision. Creasing is just as important because clean fold lines let the board bend without crushing its internal flutes. Before folding, many boxes receive printed graphics, shipping instructions, logos, or handling symbols directly onto their outer liner. Fast printing cylinders transfer carefully measured ink while sensors keep registration aligned across every moving sheet. Before folding, many boxes receive printed graphics, shipping instructions, logos, or handling symbols directly onto their outer liner. After printing, the board reaches the folder gluer, where mechanical guides begin folding its carefully prepared panels. A narrow glue flap receives adhesive, then the machine folds the panels together into a flat finished carton. The folded cartons travel through compression belts, giving the adhesive time to bond while everything stays perfectly aligned. And suddenly, the endless sheet has become a stack of precise flat boxes, ready for testing, bundling, and shipment. But a box isn't finished when it folds. First, machines must prove it can survive real-world punishment. First, sensors and cameras inspect the board for damaged edges, printing errors, missing cuts, and badly formed folds. Even tiny alignment mistakes can matter, so automated systems constantly compare production against program specifications. Then technicians measure thickness, dimensions, moisture, and bonding quality to make sure every batch performs consistently. One crucial test measures how much force a box can withstand before its walls begin collapsing under pressure. Another test measures edge crush strength, revealing how well the corrugated structure resists vertical pressure. For demanding shipments, laboratories may also test stacking, vibration, moisture exposure, and repeated handling. For demanding shipments, laboratories may also test stacking, vibration, moisture exposure, and repeated handling. And here's something machines can't completely replace: experienced workers can spot subtle texture, sound, and handling differences instantly. Only after passing inspection does the box earn its final destination, protecting products through warehouses, trucks, ships, and homes. After inspection, thousands of flat boxes gather into neat bundles, ready to leave the factory floor. Automated counters group exact quantities, while strapping machines secure each bundle tightly for safe transportation. Some factories wrap bundles for protection, while others send them directly into huge automated warehouses. Because empty boxes take less space when flat, manufacturers can transport huge quantities before anyone even opens one. Think about this. One factory can produce enormous lengths of corrugated board in a single production day. That scale explains why tiny improvements in speed, material use, and waste can save manufacturers significant money. And cardboard doesn't travel alone. It protects food, electronics, appliances, medicine, furniture, and countless everyday products. After delivery, many boxes begin another journey through recycling, returning their fibers to the manufacturing cycle. This circular journey can reduce dependence on fresh fiber, although recycling still requires energy, water, transport, and careful sorting. But the journey isn't over. Before these simple boxes reach customers, every shipment must survive one final challenge: logistics. Once loaded, these flat cartons begin a global journey through trucks, warehouses, ships, stores, and delivery networks. From a factory floor, a box can eventually travel thousands of kilometers before protecting something in your home. And here's the surprising part: the box often spends far more time protecting products than being seen itself. That means engineers constantly balance strength, weight, cost, and material efficiency when designing every new box. Modern software can optimize box dimensions, reducing unnecessary material while still protecting products during rough transportation. Newer systems also use automation, sensors, and data to control production faster while reducing errors and material waste. But sustainability brings a difficult question. How do we make packaging stronger without simply using more material? The answer increasingly comes from smarter flute designs, recycled fibers, efficient machines, and packaging engineered for exactly its purpose. Did you know the strongest-looking box isn't always the best one? Efficient design can deliver protection with surprisingly little material. And that tiny design decision can ripple across millions of packages, changing transportation costs, waste, and environmental impact. From forests and recycled paper to giant machines, every box carries a story most of us never notice. What looks like simple brown paper actually depends on chemistry, engineering, timing, pressure, heat, and thousands of precise movements. Every wave inside that cardboard acts like a tiny structural support, giving lightweight material remarkable strength. And that clever structure lets manufacturers move products safely without making every package unnecessarily heavy. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.